Hi, my name is Baptiste and today I want to talk to you about 3D printing. So nowadays 3D printing is everywhere and it can be used to print almost anything. From prototype parts or objects to complex art pieces like jewelry, customized prosthetics or organs like this ear, and even a house. It is more popular and more accessible than ever. But how does it work? So there are various types of 3D printing technology, and here we're going to focus on the most popular and the most widely available. This method is called fused filament fabrication, also referred to as fused deposition modeling. With this process, you can transform a filament of material into pretty much any 3D object you can think of. Today we're going to take, for example, this face shield here that we recently printed at Foresight. So let's dive in and see how we can create 3D objects with 3D printing. So let's look a bit more closely at our face shields. What are they? So they are pieces of personal protective equipment, or PPEs, and their goal is to protect the face of the person who wears it from chemical splashes or potentially infectious materials, which can be found in a dental clinic. So what are they made of? They're made mostly of three parts. So there's a main shield, which is a transparent sheet of material, so the person who wears it can see through it and be protected. There's a headband, here in that case the 3D printed part that we're interested in. And the back you have an elastic that allows to adjust the shields to the size of the head of the person who wears it. And we've added a layer of foam here in the back to make it a bit more comfortable for long shifts in a clinic. So now let's look a bit more closely at the 3D printed part and see how this has been made. Here is the 3D printed part by itself. It's been made by a process called fused filament fabrication, which is the most popular and affordable methods of 3D printing. If you look at the 3D printed part more closely, you can see that the surface of the part is not smooth and presents some small ridges. Each ridge you see on the surface of this part corresponds to each layer created during the printing process. So here is the 3D printer. So while 3D printers are common and relatively easy to use, as you can see, they are relatively complex machines. So let's dive in and look a bit more closely how they work to create 3D printed parts. So here we're at the back of the printer. So as I mentioned previously, the printer uses filament to create 3D printed parts. So on this model, the filament is stored in the back, and you have two spools of filament. In this case, because this printer can print in two different colors or with two different materials. So the filament is stored here and go through this tube into the printing area. So let's go back to the front and see what's happening next. So here we're looking at the printer from the top. You can see the tubes that bring the filament from the back, and they bring it to a device that we called an extruder. It's basically a motorized system that pulls the filament from the back and bring it to the printing area. And we're back in front of the printer. So you can see here the two tubes that bring the filaments from the back, the two extruders that pull the filaments, and after the extruders you can see two hot hands. And the job of the hot hands is to heat up the filament at high temperature, melt it, and deposit it in a precise location on the printed bed. Here is an example of what is happening at the beginning of the 3D printing process. In a few minutes, the hot end is heated up to a temperature sufficient to melt the filament. When the appropriate temperature is reached, the extruder is engaged and pulls the filament from the spool and push it through the hot end, effectively creating a small string of material that can be placed where needed in order to create an object. So in order to recreate a three-dimensional object, such as this face shield, we need to be able to control the hot end here in 3 dimensions. So here in this case, the hot end can move left to right, front to back, and the printed bed here can move up and down. So that gives us the 3 dimensions and the ability to reach all points in a 3D volume to recreate a 3D object. Here you can see how the first layers of the face shield are printed. The nozzle of the hot end deposits a small amount of melted filament and draws the outline of the face shield. The first layer is deposited on the printed platform, and the following layers are built on top of the previously formed layers. This way, the object is made layer by layer. When printing, the distance between the nozzle of the hot end and the printing bed is equal to the thickness of each individual layers in the final printed part. A smaller layer thickness will make more detailed objects, but will take longer to create. So now that we can control our 3D printer, we need to give it some instructions so it can move to the right location and create a 3D object. And to do so, we need a 3D model of the object to be printed. And this is done in the computer. So let me show you a few ways to get 3D models for 3D printing. So one way to obtain 3D models for 3D printing is to go to an online platform or online repository. So one popular example is this platform called Thingiverse, where user creates models and share it for free with the community. And as you can see, on this platform, you can find various models of face shields that can be directly 3D printed. Another such a repository is from the National Institute of Health, or NIH, which share some models related to science or research. So you can find models of molecules, for example, or in that case, face shields, which is what we're interested in. And the face shield that we've used here at Foresight is based on one model that can be found on the NIH website. If you want a bit more control on the design of your object, you can model it directly in a 3D modeling software. So here, for example, we have the face shield that I designed for Foresight. As you can see, the design is very similar to the one available on the NIH website, with a few differences. I redesigned the way the elastic bands are attached in the back for a bit more adjustability, and I also added the Foresight logo. So now the model is almost ready for 3D printing. It just needs to be converted into instruction that can be understood by the 3D printer. Converting the 3D model into the language of the 3D printer is done in a slicing software or slicer. The slicer divides the object as a stack of flat layers and divides them into small linear movements of the 3D printer extruder. All of these movements and additional information about the specific temperature of the hot end is then written into a file that can be transferred to the 3D printer. So now we have all the information we need to start the 3D printing process. So let's send the file to the 3D printer and see how the face shield is created.
Go for a walk, you don't have to do anything, you don't have to play, you don't have to play. You just go outside.
And there it is, a freshly printed face shield. So if you're not happy with the result, you can go back to the 3D model, make some changes, and print it again and you'll have another face shield in a few hours. So now you know how 3D objects are created. I hope you enjoyed the video, and thanks for watching.